Whammy! 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 Whammy!
Alright, a few things you need about baseball before we start. The average ball weight is approximately 0.34 kilograms. The average bat weight is approximately 0.72 kilograms. The average ball flight time is approximately 7 seconds. The average swing time is approximately 0.4 seconds. Now, the average ball speed after it's hit is usually approximately 32.6 meters per second. And the average bat speed swinging is 25.3 meters a second. The ball will stay in motion until otherwise acted upon by an outside force. For example, in baseball, when the ball is hit, it will continue to move in that path until stopped by a fielder or until it hits the ground. To determine the distance that ball is traveling, we would use the equation that we learned this year. Distance equals speed 1 times time plus 1/2 of the acceleration times time squared. First, before we can use this equation, we need to determine the acceleration by using the equation speed 2 equals speed minus speed 1 divided by time.
With the absence of air resistance, the optimum angle that would maximize the range of baseball would be 45 degrees. However, in a real situation, a baseball has many outside forces acting upon it that affects the range of the baseball. Considering air resistance and gravity, the optimum angle to hit a home run is between 30 and 35 degrees on a ball with lots of backspin and good speed.
As the bat makes contact with the baseball, its energy is transferred to the ball, causing it to fly with great speed. While in flight, the ball experiences many different forces which refers to Newton's second law of motion and gravity. It is a natural force acting upon the baseball as well as air resistance, which rivals the force of the velocity. This results in a parabolic flight path, which eventually comes to a stop when the ball is caught or hits the ground. To determine the total force acting against the ball, we use the equation F net equals mass times acceleration, and substitute average values in from the chart above.
The sweet spot of the bat is an area on the barrel that, when you hit with the baseball, creates very little vibration. This allows the momentum from the bat to pass into the baseball more efficiently than if there were vibrations created during the contact, and allows the ball to travel furthest.
Newton's third law of motion states that when a force acts upon an object, the object will exert the same force and opposite force back. This can be demonstrated through ball and bat contact. Depending on the amount of work being exerted by the player, the bat will hit the ball with a force, sending the ball further. This is due to the force the ball has on the bat is equalized with the force the bat applies to the ball. To determine the kinetic energy of a bat swing, we use the equation EK equals 1/2 mass times velocity squared. To determine the work done by the batter, we use the equation work equals force times delta D. To determine the power, we use the equation power equals work over delta T.
As for the forces that act on the baseball, while the baseball is thrown, the force of gravity is acting downwards on the ball. While it is thrown, there's an applied force that's acting on the ball, which would be the velocity that the pitcher throws it at. Also, while the ball is going, there is a normal force acting on the ball, which would be considered lift in baseball. And last but not least, there's a frictional force, well, not actually a frictional force, more air resistance that's acting on the ball that in baseball is considered a drag.
Don't just have a great night. Have an American night.